An absolute maximum is the highest value that a function obtains on its entire domain. Let's take a look at this sine wave shaped function. We want to find its absolute maximum. So an absolute maximum doesn't have to be stated as a coordinate pair. We actually just need one number, the highest elevation that our function grows to. So if we check out the peaks of the sine wave, we just want to see how high off the ground are they? How high off the axis? So they go up to a height of 3, and it never goes beyond that. So when it comes to stating the maximum value, all we have to say is that it goes up to a height of 3. That's done. Now for the minimum value, we see that our function goes as low as -3. And so that'll be the answer to that. With our sine wave, it's fairly straightforward, but some functions make it quite difficult to tell what the absolute max and min are. In some cases, there may be none. Check out this unusual function here. It's 4 minus x, but limited to a domain between 0 and 3, where 0 is part of the domain, but 3 is not. That means that we would really have a solid dot at 0, 4. But notice we have an open dot at 3, 1. Now when it comes to finding the absolute maximum value of the function, it may not surprise you to see that the absolute max is 4. It actually touches 4. But what about the absolute min? As we can see, our function approaches a minimum of 1, but it never actually touches that point. So what heights could we get? Well, here's a height of 2, and it could certainly go down to a height of 1.5. It decreases from there. So 1.5 is one of the possible y values that we could get here. 1.1 would work as well, and 1.01 and 1.0001. We could even go as far as 1.0. As you can see, this process could keep going forever. And there's no end to it. So there's going to be no value of y that this function actually settles out on. For that reason, we would say dne, or in words, does not exist. There's no one value that I can put down for the absolute min. I can't say 1, for example, because it never actually reaches 1.